Hi everybody, welcome to this recorded live session of week 7 of our spring semester 25. In this recorded live session we go through the discrete probability distributions with some examples starting from Bernoulli distribution. Bernoulli distribution is based on Bernoulli random variable and Bernoulli experiment. Then a random experiment with two outcomes 0 and 1 is a Bernoulli experiment in random variable which takes only two values as a Bernoulli random variable, where the probability that x takes 1 is p, and the probability that x takes 0, which is the other value, is 1 minus p, and usually the p is the probability of success and the probability of failure is 1 minus p, also shown by q. We can show that the expectation of this random variable is p and the variance is p times 1 minus p. For example, 47% of all AF students are female. This is based on the data. We choose a student at random. What is the chance that this student is a male? And here, p is actually 0.47. Therefore, 1 minus p, which is the probability of failure, or in this case, male, is 1 minus p, which is 1 minus 0.47, which is 0.53. That means for this student to be male, the chance is 53%. Task 1 for you guys is that consider the following example. N% of customers are satisfied with the services of a telecom company. We choose a customer at random. How much is the chance that this customer is satisfied or not satisfied with the services of the company? Choose n yourself. Of course, this n has to be somewhere between 0 and 1 or 0 to 100%. The second probability distribution that we want to discuss is binomial distribution. Binomial distribution or binomial random variables is when we repeat the Bernoulli experiment more than one time, two or more than two times. Then we get a Bernoulli experiment or Bernoulli random variable. In fact, the condition for an experiment to be a binomial is that it has to be repeated more than one time. Each time there are two possibilities in every run of the experiment, either a success or a failure. It's on or off. It is a pass or fail. It's a 1 or 0. It's a female or male, and so on and so forth. And then the outcomes of one round is not affecting the outcomes of the other rounds. That means the outcomes in each run is independent. A random experiment, which is binomial, is shown by x, binomial distributed with n, p, and q. These are the parameter of the distribution. The expected value is np, the variance is npq, the probability of success is p, the probability of failure is 1 minus p, which is q, and the probability that we get exactly x successes in n runs is n over x, p to the power of x times q to the power of n minus x, and this is actually nothing but the probability that x is equal to x. That means if we run this experiment or repeat this experiment n times, the chance that x of them is a success, is a passing or buying or something, is n over x. This is a combination of p to the power x times q to the power of n minus x. For example, if you take this online store, the chance of making a purchase when a visitor comes over is 30%. Where we get this 30%? Of course, from past data. Past data suggests that if somebody enters, the chance that he or she makes a purchase is 30%. How much is the chance that 3 persons, more than 3 persons, 3 or less than 3 persons make a purchase out of 5 visits? That means we are observing 5 visits, 1, 2, 3, 4, 5, and calculating the chance that 3 of them makes a purchase, more than 3, less than 3, and so on. So in this case, we have a binomial distribution or binomial experiment 5 times. That means n is 5. Probability of success, which is p, is 0.3, which is probability of purchase here. Q, which is the probability of failure, is 1 minus P, which is 1 minus 0.3, which is 0.7. And then we want to know how much is the chance that 3 of them, or more than 3 of them, or less than or equal to 3 of them makes a purchase. So these are the probabilities that we need to calculate, and that's something which we will be doing by applying the formula. First of all, probability that X is equal to 3, that means exactly 3% out of 5 makes a purchase. That's N over X, 5 over 3, times P, which is 0.3 to the power of X to the power of 3 times Q, which is 0.7 times to the power of N minus X, which is 5 minus 3 is 2. I have calculated already this 5 over 3. It's becoming 10 times 0.3 to the power of 3 is 0.027 times 0.7 to the power 2 is 0.49. If you multiply all these three numbers, you get 0.13, which is nothing but 13%. That is, the chance of 3 of these 5 persons would make a purchase is 13%. The same way, obviously, you can calculate, which I leave you as a task, is X less than 3 or equal to 3, for example. That would be the probability. This is actually a cumulative probability. X is equal to 0. None of them would make a purchase, plus probability that X is equal to 1. One of them makes a purchase, plus probability that X equals to 2. Two of them makes a purchase, plus probability that X is equal to 3. Obviously, in all 4 of these probabilities, you have to apply these formulas and add the results. Likewise, the probability that X is bigger than 3 is nothing but the probability of X is equal to 4 of them makes a purchase, plus the probability that X is equal to 5 of them makes a purchase. And you need to calculate both of them and then add the results. Task 2 for you would be past data suggests that the chance of a player scores from a penalty spot is n%. So that's n is something which you have to specify yourself. 80%, 70%. Where we know the 70%, we just look at the data from the past and see, okay, for example, this particular player has tried penalty kicks like 10 times, and let's say 7 of them were a success, then this would be 70%. In 4 trials, like in 4 tries, that would be n here. How much is the chance that all of them would be scored? 2 of them, or less than 2 of them, or none of them would be scored. So in this case here, n is equal to 4. X is taking different values for 2, or X is 2 or less than 2, or X is equal to 0. So these are the inputs for you, and P, the probability of success, is n%. Of course, this is something which you have to specify yourself, and then apply the formula to calculate the probability. For example, the probability that X is equal to 2, the probability that X is equal to 0, the probability that X is equal to 4, and the probability that X is less than or equal to 2. So this, remember that this last one is a cumulative probability that you have to add 0, 1, and 2, all 3 of them together.